All right, first I'd like to start off by welcoming everybody. Thank you for tuning in. My name is Kyle Garrett. I'm a junior here at McKendree University, pursuing a major in chemistry and a minor in mathematics. In terms of what my actual research is that I will be presenting to you today, we will be looking at the synthesis of an o-benzylene-2 benzimidazole dye compound for lymph channel tracing in breast cancer surgery. Now, my advisor for this is Dr. Vincent Dunlap, and this is actually a project that he has been working on for quite some time that he's now brought to McKendree for another generation of science students to begin to take over the process of research under. So part of the past 14 weeks has sort of been going through and building up a basis that we can continue on, to develop new analogs of new base compounds that we've begun developing. So as we get right into it, then we will look gradually through the process of overall what is a dye. We will look towards the specific clinical usages and the purpose of our investigation as a whole. We will then look into the synthesis pathways that we have used to get to this point, as well as some of the qualitative analysis techniques that we have used to ensure that the compound that we are synthesizing is the one we intend to synthesize. At the end, we will look towards some future development goals for the program, as well as special acknowledgments that ought to be made. So first off, what is a dye compound? Well, definitionally, a dye is a colored substance with a particular affinity to a given substrate. So it's any compound or substance that displays some characteristic hue or color that binds very well to any given surface, such as in the case of textiles, a dye that binds well to fabrics, in cosmetics, a dye that is able to bind well to the skin, but also come off easily when it needs to. Foods and paints are other good examples. And initially, these dyes were all obtained from natural sources and had very little processing. Perhaps one of the more interesting ones are the ones that have turned out to be toxic over the years, such as cinnabar, which produced the pigment vermilion, which was a mercury sulfide substance that actually led to heavy metal poisoning in those that used it in arts and paints and decor, as well as even in makeup as well. Also in lead paints as well, there were stories of infants that suffered from lead poisoning due to the lead paints that were placed inside of the room. But eventually, to sort of sidestep these toxicity hazards, as well as to promote cost effectiveness, natural dyes were to give way into synthetic dyes, dyes that we make in the laboratory, either with minimal input from nature or with more cost-effective parallel manners rather than a total buildup or workup process. The unique structures of the dyes allows them to absorb light in the visible range, which they then reflect the complementary color. So in this instance, what we mean by conjugation is this unique feature of the molecule as a whole. These alternating patterns of double bonds and single bonds. So if you look right here on this top molecule, Chicago Sky Blue, you can see that on this upper portion here, we have a double bond followed by a single bond, followed by a double bond, and it repeats throughout the rest of the molecule. This is what allows for the molecule to have that light absorption inside of the visible range, which then in turn allows it to display a visible color to us. So a large part of our research is going to be on manipulating those conjugation patterns as well as substituents off of conjugated systems in order to change the way that that light is reflected back. So in terms of clinical usage, we see that dyes are most commonly used as tracers in what is known as the sentinel lymph node biopsy. Well, first off, what is a tracer? A tracer is a dye that is used to identify and follow a flow of a given liquid. In this instance, it is going to be the lymph fluid and the lymph channels. Well, in terms of the sentinel lymph node biopsy, this is actually a process that is used to prognosticate or to essentially stage the development of a cancer. The sentinel lymph node is essentially the gateway to the rest of the body for any tumor growth. So for instance, if a tumor were to spread throughout the body, it would have to pass through a sentinel lymph node. In essence, this process is in order to determine how far the cancer has spread and how we should go forth in treating that cancer's developments. So in terms of the process, a tracer dye is injected only three of which are clinically used now: methylene blue, patent blue, and isosulfan blue. And in these, there are several complications and side effects. Two of the three dyes display toxic side effects with long-going nausea following the procedure afterwards. So it becomes important to have other dye agents that can be used in this instance as well. In terms of methylene blue, you can see from the bottom picture here that it can become very difficult to identify the differences in tones of blue. So again, another thing that we'll be looking for in this research is a contrasting dye agent. Particularly in the terms of methylene blue, this is the most used. But again, the complications arise from the inability to distinguish lymph nodes in each cluster. If you look at this bottom image, you can see that there's a very high concentration of these lymph nodes in the shoulder and breast region. Now, what this means is that it becomes very difficult to distinguish the lymph nodes in the breast from the lymph nodes in the upper arm or the upper chest and the shoulder. So in these instances where we only have really one color of dye that is being used clinically, this methylene blue color, we find that complications can arise in the actual surgery without a contrasting agent. The wrong lymph nodes can be resected and cut for the biopsy, which can lead to complications such as lymphedema, where lymph fluid can build up in the arm and lead to large inflammation, typically not proving fatal, but it is very painful for the patient. In terms of the actual methylene blue structure itself, literature values have proved to be promising for it. However, they come at the expense of challenging synthesis. We see that these nitrogen groups that come off the two sides of the methylene blue structure are actually lead to a decrease in activity for that system as a whole, which means it becomes harder to substitute positions, which means it becomes harder to substitute groups onto those positions of that conjugated system. They would draw the electron density away from those rings and make them much less reactive. So instead, we've turned to a new substance, which is this o-benzylene-2 benzimidazole. Now, in terms of this structure, it does look very structurally similar to methylene blue. It is the condensation product of two very small rings, orthophthalealdehyde and orthophenylene-diamine. Again, they have that conjugation that allows them to sort of give off light in the visible range, which, as you can see from the bottom two pictures, it shows up as a yellowish hue. Now, again, recall that we're looking for contrasting dye agents, and while, of course, yellow is not the most helpful agent in terms of contrast, this is far from being the end point. We chose this particular compound because of the ease in the actual synthesis itself. Building this molecule from o-phthaldehyde and o-phenylene-diamine proves to be very simple in terms of synthesizing it, as well as proving to add on those substituents later as well. We again see that it's structurally similar to those other common dyes. However, as opposed to methylene blue, it lacks those two nitrogen groups, which decrease the ability to substitute. So with our o-benzylene-2 benzimidazole compound, we have a higher variability in terms of how we can tune its spectroscopic absorbance, which means that we can actually add groups that change its ability to absorb light, and therefore it can give off different colors. So again, yeah, these analogs have the potential to absorb varying wavelengths of light, which create those changes in perceived color. It's far more variable than methylene blue, and so for that, we now look to the synthesis itself. Again, it is very simple. It requires the condensation of two rings to form the heterocyclic conjugated system, which you see on the right, which is our o-benzylene-2 benzimidazole compound. Again, structurally it is similar, but displays greater opportunities for substitutions. In terms of reaction considerations, this reaction is performed with an aqueous ethanol with heat for about an hour to an hour and a half. In terms of qualitative analysis, we now look to how do we measure that this is the compound we actually want to be receiving. We look to methods such as thin layer chromatography, in which small amounts of the analyte become dissolved in a volatile solvent. They're then applied to the thin silica gel film, and each compound has a different affinity for binding to the silica gel itself. If we look from right to left, we see that on the right we have the starting material, phenylene-diamine. The second from the right is our other starting material, orthophthaldehyde, and the third from the right is our supposed product, our o-benzylene-benzimidazole. Here we can track how far the reaction is proceeded by where spots fall on the chromatography, gel. We see that we have two clear spots for the phenylene-diamine and the phthaldehyde. And on our third point, we see that we have a few spots which may indicate leftover reactants, as well as a clear third spot that is not present in the other, which is indicative of the substance that we intend to produce. In terms of future work, we look to considerations for substitutions along the R1 region. We believe that these will change overall the spectroscopic properties of the molecule. And furthermore, we intend to get spectroscopic characterization of those analogs in the future as well, either such as processes like UV-Vis or NMR studies. Furthermore, we also will be looking to cellular toxicity studies. This may be a ways off, however, and may also provide a valuable impetus for collaboration in the scientific community as a whole. So in terms of references, in terms of acknowledgements, we have Nigel Bennett, one of my lab partners, just all around benefit or all around great help in the lab. Mr. Paul Lega, scientific materials manager for supplying the reagents and supplies that we need in our research, as well as Dr. Joni Bastian for leading us to the student engagement grant and helping us acquire funding for our research. We are much appreciated. Or very appreciative. In terms of questions, feel free to email either me at kyle.garrett18@mckendry.edu or my advisor, Dr. Vince Dunlap at vkdunlap@mckendry.edu. All right, thank you for tuning in.